Alright, here we go with this review sheet for the year. So the first one, number 1, says factor completely. So let's go ahead and look for a GCF. So when I do that, I notice both of these divide by 2, so I'm going to pull out a 2. Also, they both have an a that I can take away. So that, or divide out. That leaves me with a squared minus 81, and then I can factor that even more. There's a difference of 2 squares. So 2a, that turns into a plus 9 and a minus 9. Alright, now somewhere's fix that up. Alright, identify the solution set of this equation. So when I look at these multiple choice answers, they all look like they come from the quadratic formula. So I'm going to go ahead and use that right here. I have to put it in the proper order, so 3x squared should be first. And this x has to come up to the other side, so plus x and then plus 3. So it looks like my values are all positive. So a is 3, b is 1, and c is 3. Those are the values that I'll be plugging into the formula. So I get x equals negative b, so that would be negative 1 plus or minus square root of b squared minus 4ac. Now remember, this part inside here is called the discriminant, and it does a lot for you. It tells you what kind of solutions you have, real, imaginary, or just 1 or 2 solutions, things like that. So b squared, that would be 1, because 1 squared is 1, minus 4 times a and c. Well, a is 3 and c is 3 as well. Over 2 times a, so 2 times 3 is 6. So if I clean that up, that comes to negative 1 plus or minus the square root. 1 minus 4 times 3 times 3, so that's 4 times 9, that's 36. So 1 minus 36 is negative 35. So if there's a negative 35 in here, that means I'm going to put 35 there, put an I out front, because it's an imaginary number. Alright, all over 2 times a, so 6. Alright, so it's looking like letter D. Nope. Letter B. Alright, so solve this next equation by factoring. So if you want to factor, everything has to be together on one side, so let's pop this in the middle here. So I got 3x squared plus 7x minus 6. So let's go ahead and set it up. We got 3x and x, so things that make 6. So we'll have 6 and 1, 3 and 2, and that's it. So I think I'll try 3 and 2 first. I can't put my 3 in my first parentheses, so I'll try 2 here and 3 there. Let's check it out. 9x, yep, 2x, okay, I can make 7. Positive 9 minus 2, so minus 2 plus 9. So to finish solving this, I would take each of those factors, 3x minus 2, and set them equal to 0, and solve them. X plus 3 equal to 0, solve that. So solve this one, you get positive 2/3. Solve this one, you get negative 3. So my solution set is 2/3 and negative 3, if you want to write it as a set. Alright, so moving on, describe the transformations. This is our good old absolute value graph. Remember, the absolute value graph is this V-shaped graph that goes right through the center there with a vertex at 0, 0. So this would move the graph, these minus 3 plus 8, that would move the graph left 3, and it would also then move it up 8. So that's what I'm going to say. So that was also able, you can do that in Desmos as well. You can type this in, type both buttons, see the difference. So right 3, oh my gosh, and up 8. So I bet you guys were like, no, you made a mistake. Yeah, it's right 3 and up 8. Sorry about that. Sorry, I didn't mean to confuse you. I keep doing that. I did that one other time as well. Alright, so number 5, the solutions to the system of equations. So notice I have 2 parabolas. So the system of equations, the solutions are the places where they intersect each other. So that looks like 0, negative 1, and the other place looks like about negative 3 and 2. So negative 3 and 2. Alright, good. There it is. It's kind of a little small. Alright. So number 6, we're going to have to type in ourselves. So I think I will do that here. Let me see. I have 2, and you know what? You don't even have to solve for y. Type in 2x squared minus 2y equals negative 12x minus 2. And you know, it would be nice if you would solve for y, but we don't have to in Desmos. Next one, 2x plus y plus 14. Okay, so it's a parabola and a line. And so I am looking for where these things intersect. So, looks like they intersect here. At negative 3, negative 8, and also at negative 5, negative 4. So negative 3, negative 8, negative 3, negative 8. Check one more time. Negative 5, negative 4. Okay. Now, if you do have to solve these for y and put them in a calculator, then to do that, you'd want to start by moving this 2x squared over to the other side. So this problem would become negative 2y equals negative 2x squared minus 12x minus 2. And you divide every single part by negative 2, producing x squared plus 6x plus 1. Then here, you want to move the 2x and the 14 to the other side. That would produce y equals negative 2x minus 14. So then you would go and graph those two equations. They would come out the same as what we just did in Desmos, but if you needed to solve for y to put them in the calculator or something, that's what you'd have to do first. All right, so let's see which equation most likely represents the data in the scatter plot. So first of all, this data looks quadratic to me and upside down. So this is a line, this is another line, a linear equation. These are both parabolas, but only this one has a negative in front, meaning it would be upside down. So that's the one. All right, number 8, find the intervals where this graph is increasing or decreasing, and also state the end behavior. So we'll draw a little graph here. Let me go to my Desmos. All right, so it looks like we got 2x to the third. Y equals, because I like to. Alright, so I paused the video a little bit there so that we don't have to wait for me to do that. Alright, so here's my picture. Looks like, oh yeah, it goes way up, it crosses the y-axis at 20, so it goes pretty high, but I'm interested in the end behavior and the x-intercepts. So there's an x-intercept there at negative 2.5. There's another one at positive 2. Right, so let's see if I can sketch this. Negative 2.5, so it comes up through negative 2.5, comes way up, comes down, bounces at 2. So 2, and this is at negative 2.5. Right? Actually, I wasn't interested in the x-intercepts, but I'll leave them there. Okay, so if I'm going to name the increasing and decreasing areas, I actually need this little point up here. So I'm going to go back and grab that. So let's see. Pull this graph down. There we go. So that point up there is negative 1 and 27. So this little spot right here is at negative 1 and 27. The reason I needed that spot is because that is where it changes from increasing to decreasing. So this graph is decreasing right in the middle. See, this section right here is decreasing. So between negative 1 and 2, this is decreasing. Remember, we use x values to name the area. So from negative 1 to 2, this thing is decreasing. After 2, it's increasing. So from 2 to infinity. And before 1, it's also increasing. This section is increasing. So before 1 would be from negative infinity to negative 1. Sorry, negative 1. Okay, the end behavior, as x goes to negative infinity, so when we're on the left-hand side, the graph is going down, so that's negative infinity. As x is going to positive infinity, on the right side, this graph is going up. So there we go. All right, now the next problem, I want the zeros and the factors. All right, so here's 5, 1. Remember, zeros are x-intercepts, and then there is negative 5. So my factors would be x minus 5, the opposites here, x minus 1, and x plus 5. Now, remember this, that if one of the zeros had been something like let's say 2/3. Remember, the factor that goes with that would be 3x minus 2. Or if a 0 would have been like negative 1/2. Remember, the factor would be 2x plus 1. Okay. All right, here we have to multiply these together to work this out. So I'm going to have the cube root. 16 times 2 is 32. I get x to the 6th and y to the 7th because I add my exponents. All right, so I can break down 32. I got 16 times 2. Then I have 4 times 4, and then 2 and 2 for each of those. Now remember, I'm looking for triples, so there's 3 2's. So 2 is going to come out, and these 2 2's are going to stay in. So 2 comes out, a 2 comes out, and then leave a little space. 2 times 2, so 4 stays in. So already I can see the answer would be letter B. But just to finish this off, 3 goes into 6 twice, so x2 comes out. 3 goes into 7 twice, so y2 comes out, but there's 1 left inside. Okay, so number 11. Rewrite this in exponent forms without a radical. So cube root of 64. So I'll go back. The cube root of 64 is 4, but you can also go to Desmos and do that. So we would just need something like functions, maybe it's under miscellaneous. Yep, there it is. We want the cube root of 64, and then you can see that it's 4. Or you just know that it's 4. Alright, so that part's going to be 4. 3 goes into 9, so I would put x to the 9 over 3. Well, 9 over 3 is 3. And y would be 7 over 3, and that doesn't reduce, so I'm done. Alright, for number 12. Number 12, I'm going to be canceling some things out, but I need to factor it first. So 7 minus 2b does not do anything. 54b does not cancel at all. Remember, I have to flip this because it's division, just multiplication. So 18b plus 6 comes up, but I can take a 3 out of that, which then makes 6b plus 2. Oh, wait a minute. I could take a 6 out. Oh, bigger than 3. Better, better, better. So I should be taking a 6 out, not just a 3. Alright, so take a 6 out. That would leave me 3b plus 1. So I noticed that when I was only taking a 3 out, it was still having a 2 in common. That's why I took a 6 out. Alright, this guy up here, I'm going to work on factoring that. So, let's see. 6b squared. So notice this over here. I'm probably going to want some cancellation, right? I'm probably going to get lucky, hopefully, with that. So let me try 2b and 7. So 2b and 7 here. And if that's a 2b, then this would have to be a 3b, right? Because 2 times 3 makes me 6. And then 7 times 1 makes 7. Let's see if that, because then I'll get some good cancellation going on. So this part makes 2b. This part makes 21b. Oh, and that's 19. Negative 19 would be negative here and a positive there. So negative and positive. Alright, so 2b minus 7 and 3b plus 1. Alright, so we have this cancellation. We also can cancel this with this. They're opposites, so I put a negative sign. So I'm almost done. 6 goes into 54 9 times. So 6 can cancel with this and make a 9. So my final answer, when I collect everything together, on top I have nothing but a negative, so I'll have to put negative 1. On the bottom I have a 9b. And that would be my answer. Alright, number 13. 13, remember I kind of look for a common denominator. Now, you know, multiple choice, you could go and like plug these numbers in for all the x's and see if you get it equal to negative 1/6. But I'm going to do it like the mathematical way, like of like solving, but you can always very well do that. But if 3 worked, you'd want to check 4 as well. So anyway, and any of these other ones. Alright, so it looks like my common denominator would be 6x. So I'm going to pretend I'm multiplying everything by 6x. So 6x times this. Well, the 6's would cancel, so I'd be left with x times x minus 2. Minus, when I did this part, well, the x's would cancel, so I'd be left with 6 times x minus 2. Equals, now here, the 6's would cancel, so I'd be left with negative 1 times x, so negative x. Alright, so let's work this out. X squared minus 2x minus 6x plus 12 equals negative x. Clean this up. X squared, negative 2x minus 6x is negative 8x plus 12. So I had to add x to both sides so that I get that together. So x squared minus 7x plus 12. Alright, so I'm going to factor that. So x and x, 3 and 4 make 12, and also make 7 if they're both negative. So my answers are 3 and 4. And I go back and check, would I be allowed to put a 3 or 4 here? Yes, I would just not be allowed to put a 0 there, but I don't get there. So 3 and 4. Alright, same idea here. My common denominator is x and x minus 2, so notice that this is a combination of these two, so I'm going to choose that for my multiplication piece. So now I imagine x and x minus 2 times that part. Well, the x minus 2's would cancel, so I'm left with x times x minus 1. Plus, now, times this part. X's cancel, so I'm left with 5 and x minus 2. Here, everything cancels, so I'm left with a 2. And that's how we flatten our problems. So I have x squared minus x plus 5x minus 10. Okay, so, equals 2. 0. That was going to cause a problem. Alright, so I got x squared plus 4x minus 10 equals 2, because the negative x and the 5 made 4. So I got to take away 2, so I get x squared plus 4x minus 12. Alright, so I'm going to go factor it. Alright, I think I'll use 6 and 2, so x plus 6 and x minus 2 make this expression here. So my answers are negative 6 and 2. But I have a problem with that, because I could not put a 2 here. 2 minus 2 would be 0, and so I can't accept that. That's an extraneous solution. So if it was multiple choice and there was a negative 6 and 2 listed, I would not pick that. But if there was something with only negative 6, that's the one I would pick, because I can't use 2. Alright, number 15. This is asking for inverse. So inverse is, remember, where you reverse the x and the y. So this really means y. So I'm going to switch it to x equals y to the third minus 8. So I'm going to solve for y. 8. So x plus 8 equals y to the third. To get rid of a y to the third, I do a cube root. So cube root. So this knocks each other out. And then I get y equals cube root of x plus 8. Now, y, this started off with g of x, so this would be g negative 1 of x. That implies the inverse. And there's my answer, cube root of x plus 8. So there it is. All right. To identify the domain of this picture, so remember the domain is the width. So when I look at this picture, I see something going on to the right of 2, so including 2, and to the left of negative 1. So that means my domain would look like negative infinity to negative 1, but not including negative 1, because you see it stops right here. Or I could also get x values from 2, but actually I should use a corner bracket for that, because it's including 2. So I want to do this 2 to infinity, so 2 on. So from 2 to the right, from negative 1 back. You could also say it like this: x is less than negative 1, or x is greater than or equal to 2. So you can say the domain either way, with inequality symbols or interval notation. Alright, number 17, we're trying to factor this. So these, hopefully you recognize, are perfect cubes. 125 is 5 times 5 times 5. 343 is 7 times 7 times 7, so 7 cubed. So remember, when we factor this, we have a little piece and then a larger piece. So in the little piece, you break this down. This came from 5m. You can do the cube root of it. This came from 7. And over here, remember, you square, multiply, square. So this may take a minute to remember, because we didn't do this very often, but we did do it. So I square the 5m, and I get 25m squared. Notice I have no signs. And I multiply these together. That makes 35m. Then I square the 7, so 49. Then we come through with our signs. Remember, SOAP. SOAP means same, opposite, always positive. So you put the same sign as the original here, and do the opposite sign, and then I do always positive. So when I look over at my answers, I guess it's answer B. Right. Yep, looks good. Alrighty. So down here, number 18, another inverse. So remember this means y, so I'm going to start off switching it. X equals cube root of y minus 4 plus 1. So I'm going to take away 1. So we get x minus 1 equals the cube root of y minus 4. So this is the opposite of the other problem that we did just a minute ago. Now I'm going to cube everything to get rid of my cube root. So that brings me to x minus 1 to the third. The cube root and the cube knock each other out, so I got y minus 4. So I just got to pop my 4 to the other side. So I get x minus 1 to the third. It turns into a plus 4. And, you know, it's supposed to be y equals, but we're going to write it as the inverse. My answer, x minus 1 to the third plus 4. Alright, synthetic division. Alright, synthetic division. So this was where we were trying to divide x minus 4 into here. So you put the opposite number in the box, you put the 0 in the box, and then you go through and you put all the coefficients. 7, negative 5, 1, and 2. And there's nothing missing. 7, negative 5, 1, and 2. Leave a space, draw a line. Bring this first number down. 7 times 4 is 28. Remember, we multiply, then we add. It makes 23. 23 times 4 is 92. Then I add. Oh, this is not looking pretty. Alright, 93 times 4. Let's see, I need a calculator. 372. And I add 374. So that's my remainder. So remember, my answer gets knocked down a level. This was x to the third, so this is x squared. This is x, and then we're done. So my answer is 7x squared plus 23x plus 93 plus, remember I put my remainder, over what I was dividing by. Alright, and that's it. Alright, number 20, we're trying to solve this, so we're going to take away 12. So I get the cube root of 2x minus 5 equals negative 4. Now, equaling a negative is okay for a cube root. You can do the cube roots of negatives and get a negative answer. If it was a square root, I would stop here and say that there's no solution, but this is possible. So to get rid of a cube root, I do a cube power on both sides. So that leads me to having 2x minus 5 pop out, and negative 4 to the third, that would be negative 64. Alright, so I'm going to add 5 to both sides. So I got 2x equals negative 6, nope. So I got 2x equals negative 59. So x equals negative 59 over 2. Or you can divide it out to the decimal. Alright, number 21. Basically supposed to put these things together with a common denominator. So my common denominator would be x minus 2 and x plus 5. So the 4x is going to get the x plus 5. And the 6 is going to get the x minus 2. And we work that out. So this becomes 4x squared. This becomes plus 20x. This becomes negative 6x. And this becomes plus 12. So on top, on the numerator, I get 4x squared plus 14x plus 12. And in the denominator, you can just go ahead and leave those. X minus 2, x plus 5. Now, technically, I should check to see that if I factor the top, if anything cancels, but we're not going to be that mean to you. It doesn't. And so, we're all done here. I'll just check real quick, but let's check. I can take a 2 out. That leaves me 2x squared plus 7x plus 6. And I'll check and see if that factors 2x and x. 3 and 2. Oh, it does. 3 and 2, so that makes 4, and 3 makes 7 plus. But you know what? None of those pieces match anything in the denominator, so it wouldn't matter if it factors anyway, because nothing cancels. So you can be perfectly fine with this answer right here. Alright. Number 22. Alright, we're almost done, right? Right? Is this the last page? Okay, phew, I'm getting tired. All right, so what is the equation of the vertical asymptote and what's the domain? All right, so remember your basic log function. Your basic log function has a vertical asymptote right here at x equals 0. And then your log function comes over here like that. So if I move this thing up or down, it doesn't matter. Like if I move this thing up, the asymptote doesn't change and the domain doesn't change. But, because right now the domain is everything to the right of 0. But when I move this thing to the left 12, then that becomes my new asymptote. This is at negative 12 right now. So there's my new vertical asymptote, x equals negative 12. Also, when I move it left 12, the green graph follows, and so it only exists to the right of negative 12. So the domain changes as well to be all the numbers greater than negative 12, because it's existing to the right of negative 12. Or you might see it like this, negative 12 to infinity. Okay. So you can graph that on Desmos, but it might be a little bit annoying because it's kind of a bigger number. All right, what number is a 0 of this exponential function? So the key thing here is to remember 0. 0 means x-intercept. So all it takes, I put this Desmos thing here. So look at the graph, 25 to the x minus 125. So let's take a look. 25 to the x minus 125. Okay, so let me just look at my graph. Okay, where is that axis? There it is. So there's the x-axis. There's the x-intercept at 1.5 and 0. Okay, what is the equation of the asymptote of this graph here? So remember, this is an exponential function. It's a growth problem. Normally, exponential functions are going to come across like this. They have an asymptote of y equals 0 normally. So moving this graph to the right or left doesn't change a thing. It doesn't change the asymptote at all. Right? So if I move this thing right or left, it just slides across that way. So I don't really care if I move it right or left. But when I end this one too. But if I start to move it up or down, then I have to change it. So this thing is moving down 4. So down 4 makes my asymptote there, and my graph moved down 4 with it, and I guess to the right 5 as well. What I'm interested in is the down 4 motion. So my new asymptote is not y equals 0, it's y equals negative 4. All right, this next one, which one of these is a 0 of this function? So you can do this a couple different ways. The easiest way to do this is the graph. So again, graph this, log of 4x minus 1. So looking at functions, I choose log of 4x minus 1. And I guess I could put y equals over here. Doesn't really matter. I want that right there. There's my 0. There's my x-intercept at 0.5. So there it is. All right, horizontal and vertical asymptotes. Okay, so you can graph these, but the rules are the vertical asymptote comes from the bottom, whatever makes the bottom 0. So that would be x equals negative 7. And the horizontal asymptote comes from your rules. Well, look at this. The x's, they match. So that means I take the numbers in front, the 3 and the 1. So my horizontal asymptote is going to be y equals 3 over 1, which is 3. Down here, I'm going to have to factor this a little bit. So 2x. The bottom factors into x plus 4 and x minus 4. So I got two vertical asymptotes, one at positive 4, one at negative 4. And now the horizontal asymptote comes from the rule again. Look at that x compared to that x. The top is smaller than the bottom. So that means automatically when the bottom has a greater degree, automatically y equals 0 is our asymptote. Okie doke. So quadratic formula. If the discriminant of a quadratic function is greater than 0. So remember, the discriminant is the part inside the radical. So that means, I'm going to have a plus or minus, and it's going to be a positive number in here, like let's say 10 or whatever. And then I got a number here and a number there. So I'm going to have two answers, two real answers. There's no imaginary solutions here. There's no negative under the radical. So I'm going to have a number plus radical 10 over another number, and a number minus radical 10 over another number. All right, so that's two real answers. And the graph will cross the x-axis 2 times that I can see, right? If the graph doesn't cross the x-axis at all, that means there's no real solutions, right? And then a graph can cross the x-axis like one time, that means there's one real solution. Okay, and that's when your discriminant is 0, but anyway. All right, number 29 changes to log form, so I'd write log base 4, because that's my base here, of 64 equals 3. So remember the cycle that it has to follow. 4 to that power equals this number here. Okay. All right, so for number 30, oh yay, last problem. All right, so this is a decay problem because the base is less than 1. So I can kind of figure out the graph right here. The asymptote is 3, so I got 3. It's decaying, so it's coming down. Okay, you can also graph this on Desmos just as easily. So as x goes to negative infinity, so the left side of the graph is rising up, 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 up. As x goes to positive infinity, that's the right side. So that is staying at 3. So it's staying at 3 right there. Okay? And that would be all. Good luck. See you in class. Bye.